yes I can, gang, gang. Hey, gang, gang. Oh, yeah. Yes I can, 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 yes I can. Oh yeah, all dog pull up in a white van. Yeah, hey, slide dog, you know he a hype man. Yes I can, 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 yes I can. Hey, can't see Ogden as he run past. Coach Matt been serving up the good fast.
Shake Ogden's hand as I walk in the class, turning my home phone and so on my past. Start up my warm up because I'm succeed. I get the thing done and I do the math deep. Grabbing these points and I'm making it right. I'm saying hello, I'm catching these flights. If nobody's nappy, the class will be happy. And nobody making a frown. Okay, class, one more time. Kiss the colonel and raise your hand if you are sitting down. Yeah, just give me 20 on 3. Come on, let's see who the best class is going to be.
Welcome, Yicksters, to the first ever KYIC News Channel 17 on your TV dial. Hey, I trust that you and your family are healthy and happy and staying sane during this crazy time. Alrighty, so hey, our goal every week, the broadcast will come out on Monday, is to bring you some positive news, make you smile, and teach the algebra lesson of the week. Your lesson will be due, your home fund will be due on Friday of that week. But again, if you have problems or getting online or whatever it is, please let me know, and it's very flexible. But every Monday, I'm going to give you a link. It's already in Google Classroom, and it's going to be either to Khan Academy or to YouTube or to something else that will explain the lesson that I'm going to explain, maybe even more, maybe different detail, maybe a different voice to help you understand it. Hopefully, this info will be enough for you to be able to do your assignment. However, if you're confused, like some people are apt to be in a college algebra class or algebra 2 class, you'll be able to come to my office hours, which will be on Tuesday and Thursday from 12 to 1, and that link is going to be in Google Classroom. It should be in there already. Some of you have already joined me last week. But if you have any questions, comments, concerns, join us Tuesday and Thursday from 12 to 1. And if it gets too complicated with both classes on Tuesday and Thursday, then we're going to split the classes. Say, for example, Algebra 2 will be on Tuesday and College Algebra will be on Thursday. So we'll deal with that when time comes. But again, just to recap, if you're confused after today's lesson, I'll be available Tuesday and Thursday from 12 to 1 for a Google Meet. If anybody wants to join us, if you bring me a frap, good things will happen, and perhaps some free toilet paper or something like that. So join and have some fun. Hey, you guys still with me?
Yes.
Are you sure?
Yes.
Alrighty then. Hey, in addition to the algebra news of the day, we will provide weather, sports, and feel-good stories, and perhaps even a few guest speakers. Now, not many speakers at my house, but I do have my 3 kids, my dog, 2 cats, and a guinea pig that will probably join us sometime in the near future. And, of course, the quote of the day, and number 5 question for those of you who like outside-the-box thinking, and many surprises. Now, also, in addition to all that, if you know of a classmate or a friend who has a birthday, please privately email me so we can wish them a happy birthday.
Fun.
Welcome back. Hey, we just want to thank our sponsors for this KYIC News telecast. One of them, of course, is a favorite of mine, Starbucks. And the second one is a big favorite of everybody who's been in my classroom, and that's Sassy Flakes, sponsored by Kellogg's, because they're great. Now, if you want to know where to find these 2 items, they can be found in any grocery store. Of course, Costco in aisle 317, where the toilet paper used to be.
One.
Thank you. Now let's get started with our KYIC news. First of all, quote of the day. Quote, "Only in the darkness can you see the stars." Unquote. Again, only in the darkness can you see the stars. Any guess who said it? Foster. Martin Luther King Jr. Nice job, Foster. Anyone want to translate that? I'll let you guys think about that. Hey, second of all, let's get a weather update from a weather report. Let's take it outside.
Thanks for all that news. Welcome to today's weather forecast. It is currently raining, and there's a 99.9% of algebra thunderstorms coming up, so keep an eye out for that. Now I'll send it back to the desk.
Thank you for that fantastic weather report today. Now let's go over to the sports desk and see what's happening in the world of sports. Thank you, desk. Hey, in the sports world today, I don't know if you guys are aware, but there's not much going on. However, I would like to thank and congratulate the San Diego Padres. After 2 weeks, they have yet to lose a game. So congratulations to the undefeated San Diego Padres. Back to you at the desk.
1.
All right, thank you for that great sports report. Congratulations to those Padres. Hey, now, the reason we're here, people. The most important news at all this week will be the algebra news. Let's take it to the algebra desk and find out what's happening. Hey, in the world of algebra today, this week, we have a lot going on. I have to tell you, you college algebra youngsters, we have chapter 6, section 3, which is solving 3 variable equations. It's not easy. Put your grit pants on. Put that growth mindset on, because we're going to go through a couple examples, and then you're going to be on your own. So please pay attention, and let's get to work. Is this going to be possible, people?
Yes.
Can we do this?
Yes.
All righty. Here we go. Okay, 6.3, solving 3 variable systems. Here's example number 1. You should probably pause this video so you can just copy it down at your own leisure. But just to make sure you can see this, I will tell you what it is. Put down equation number 1, x minus 2y plus 3z is equal to 9. Equation 2, negative x plus 3y equals negative 4. And lastly, equation 3, 2x minus 5y plus 5z is equal to 17. Coincidence? I think not. Okay, step number 1 in solving a 3 variable equation. You should write this down maybe separately. Step 1, pick 2 equations and eliminate 1 variable. 2 equations, eliminate a variable. Well, since we already have no z in equation 2, we've accomplished our first step. So we don't have to worry about the first step. Step 2, write this down, 2. Step 2 is to eliminate the same variable in 2 different equations. So that means we have to take equation 1 and equation 3 and eliminate a z. That's my dog going crazy right now. I'll come back to you. Okay, my dog settled down for a second. Let's continue. First step, we eliminated the z because it was already gone. Step 2, we have to eliminate a z with the other 2 equations. Can someone tell me what can I do to eliminate the z's in these 2 equations? Serafina, what do you think?
Yeah, baby.
Good job, Serafina. Let's multiply the top equation by negative 5 and the bottom equation by 3, so my z's will cancel. So it looks like this. I'm taking equation 1 and multiplying by negative 5. And I get negative 5x. I get positive 10y. I get negative 15z is equal to negative 45. If you have any questions, pause it, think about it. I'm going to multiply the equation 3 by negative 3, so I get negative 15z there. So take equation 3, multiply by 3, and it makes it easier if you have your equations numbered, and you can just put the factor in front so it comes out nice and clean. 3 times 2 is 6x. 3 times negative 5 is negative 15y. 3 times positive 5 is 15z. And 3 times 17 is 51. Now you may notice something is going to happen here to the z's. They will cancel. And we end up with, adding these two together, you get x minus 5y, z's cancel, is equal to 6. So now we have a two-variable equation. We have another two-variable equation up here. What are we going to do next? Let's solve that two-variable system, which is what we did before the pandemic. We'll do that right now. Okay, are we still with me?
Yeah.
Are you sure?
Well, yes.
All right. So we have our new two-variable equation. We take our two-variable equation from our original problem, which is negative x plus 3y equals negative 4. Now let's solve that, which we can do pretty easily because if we add those two together, what happens to the x's? They cancel. Now we have negative 5y plus 3y is negative 2y is equal to 2. Divide both sides by negative 2. And y is equal to negative 1. Y is equal to negative 1. Does anyone have any idea? How do we get the second variable? Michelle, how do we get the second variable? Good job, Michelle.
Give me a Y. Give me an E. Give me an F. Yeah.
We just put negative y back into one of these two equations and we solve for x. Let's just go back to the first one. So we get x minus 5 times negative 1 is equal to 6. You get positive 5. Let's subtract 5 on both sides. And x is equal to 1. So we have x is equal to 1. Y is equal to negative 1. And how do we get the third variable? We plug these two back into one of the original equations. Let's just go back into the first one, which is x minus 2y plus 3z is equal to 9. In place of that x, we're going to put a 1. In place of the y, let's put a negative 1 plus 3z is equal to 9. Negative 2 times negative 1 is 2. Okay, so we're going to plug in the negative 1 for y, the x for 1. Solve this. You get 3. That's minus 3 on both sides. And 3z is equal to 6. Z must equal 2. Now, I got to tell you, if these are not nice, clean integers, something is wrong. If we have a nice fraction like 1/2, you're on the right track. But I'm not going to give you an ugly fraction. So my answer is, step number 5 is make sure we write this as a coordinate. My x is 1, my y is negative 1, and my z is 2. Congratulations, you just solved your first 3-variable system. And make sure you do the happy dance. Okay, let's step up the game a little bit. Example 2, our last example, by the way, will be a little bit more difficult. So put your grip pants on. Put your grip pants on. Have a positive mindset here. And let's do it. Can we do this?
Yes.
Okay, here we go. Now we have to pick, step one, again, this is pick one variable to eliminate from these two equations, from two of these three. Obviously, what would be easier? Let's look at the z's. Because I have a 1z there, I can easily cancel these two if I multiply that by 2. And then I can cancel 1 and 3 by multiplying equation 1 by 7. So that's what we're going to do. We can also cancel the y's here because that coefficient is 1. So what you want to look for is a coefficient of 1. So let's multiply equation 1 by 2, and then again, equation 1 and equation 2 will cancel. So here we go. Multiplying equation 1 by 2. Check my math, make sure we're doing this correctly. 2 times 3 is 6x. 2 times 4y is 8y. 2 times negative z is negative 2z. And 2 times 17 is 34. Okay, now let's take this equation, which we just came up with when we multiplied equation 1 by 2, and we're going to add it to equation 2. Watch what happens. We get 5x minus y plus 2z is equal to negative 2. Look what happens to the z's, people. They are eliminated. We get 6x plus 5x is 11x. 8y minus y is 7y is equal to 32. Makes sense so far? All we did was step number 1, eliminate one variable. In this case, we eliminated the z's. Now for step 2, we got to do the same thing with two different equations. So instead of 1 and 2, let's go 1 and 3 by multiplying this by 7, so the z's will cancel again. Here we go. Okay, we multiply equation 1 by 7, so again we get negative 7z plus 7z, and they will cancel, which is then we're going to take care of this one down here, the two variables. So stay with me. So 7 times 3 is 21x. 7 times 4 is 28y. 7 times negative z is negative 7z. 7 times 17 is 119. We're going to add this to equation 3, where we go 2x minus 3y plus 7z is equal to negative 21. Do you see what's happening now? The z's will cancel again. So we end up with, we get 23x plus 25y is equal to 98. So now we have this two variable equation. We have this two variable equation. Can we put those together and solve the two variable system? And the answer is yes, I can. Make sure you copy that down, and we'll get back to you. Are you still with me?
Yes.
Okay, good thing. Okay, we have a two variable system, and we have another two variable system. Now we're going to put them together because we eliminated the z 2 times. What can we do to eliminate a variable with both of these two equations? Good answer, Summer. We can multiply the top by negative 7 and the bottom by 25. Let's multiply this one by negative 7 and the bottom by 25. Could we have also multiplied the top equation by 11 and the bottom by negative 23? Yes, we could. Either way will work. Let's multiply this out and see what we get. Negative 7 times 23 is going to be negative 275. Check that. 7 times 23 is going to be negative 161. X. 7 times 25 is going to be negative 175y. And 7 times 98 is going to be negative 686. Let's do the same thing to the bottom. 25 times 11 is going to be 275x. 25 times 7 is going to be 175y. Look at that. And 25 times 32 is going to be 800. And once again, something beautiful happens. The y's are gone. 275 minus 176 is going to be 114x equals 114. X must equal 1. Congratulations. We have a nice clean integer. How do we find the other variable y? Any guesses? Annie, good job. You take the 1, plug it back into one of these variables, and you get your y. If I do that, I end up with 275 times 1 plus 175y is equal to 800. Solve this for y, and you get y is equal to 3. So congratulations, we have 2 of our variables, and they both came out clean. How do we find our last variable? Steal. How do you do it? You plug them back into the original equation, any one of the original equations, and you can find z. Let's do that right now. Okay, we have the x and we have the y. X is equal to 1. Y was equal to 3. Plug those 2 variables in to any one of the original equations. I just chose number 1. Plug those in. Solve this. You get 3 plus 12 minus z is equal to 17. 12 plus 3 is 15, minus 15 on both sides. And negative z is equal to 2. So positive z is equal to negative 2. We're getting really close, people. Our last step is to write this as a 3-variable coordinate. My x is 1, my y is 3, and my z is negative 2. Cha-ching, bada-ba-bing. Our last step is the happy dance. Okay, given you 2 examples, solving 3-variable systems. It's not easy. Do the best you can. The assignments in Google Classroom. I'll be here for help Tuesday and Thursday at 12 o'clock. If you have any questions, the answers are in the back of the book, I think, except for one problem. I'll give that to you if you need it. And put your grid pants on. Have a growth mindset. Take care of yourself. Do the best you can. If you have any questions, problems, complaints, email me or come on my office hour tomorrow or Thursday. Good luck, people. Make it a great week. Talk to you later. Bye-bye. All right. You still with me?
Yes.
Are you sure?
Yes.
Good deal. Hey, I want to thank you for tuning in today. I hope you understood the lesson. And if not, feel free to come in my office hours, Tuesday and Thursday at 12, or email me anytime. I'll get back to you, and we'll go from there. Now, we will leave every newscast with a number 5 question. The first person to get back to me with the correct answer will win a roll of toilet paper. So here's the question today, people, this week. A clock loses 10 minutes each hour. If the clock is set correctly at 12 noon, what is the correct time when the clock reads 3 p.m.? Good luck, and make it a Yes I Can week.